Hey you guys, welcome back to the channel PHYSICSSIRJEE, and this is the JEE Mains extra syllabus previous question paper solution series that I have started last week due to some unforeseen circumstances and me becoming busy with my own students who are preparing for JEE Mains examination. I could not actually continue the series, but instead of leaving the series, which I promised as 8 videos, taking up all the question papers, extra syllabus of 2019 and 20, we were going back. I think we finished 2020 papers. We were in 2019 April shift, and also January, some of the shifts were left out. So what I am doing is, I'm going to make the highlights of the 5th to 8th video. Okay, so first 4 videos were complete, and 5 to 8, instead of making 4 more videos, I'm going to finish off the things with these 4 under the pretext that the concepts that were covered elaborately in the first 4 are not going to be repeated. So I have removed some questions, so only the new challenges have been put up in this particular format. So I hope this would be helpful for you before your JEE Mains examination. So let's move forward. So these are the shifts that we are going to connect with. So all the April shifts of 2019 that were pending after video 4, and all the January 2019 shifts. Actually, these papers were slightly tougher as compared to the 2020 shifts. So we will go forward. So this is the first question, and every time you want to do a question, just pause and then only go to the solution. So especially if you are not having the exam immediately. Okay, so an NPN transistor is used in common emitter configuration as an amplifier with 1 kilo ohm load resistance. Signal voltage, that is input, is 10 millivolt, is connected as applied to the base emitter junction. This produces a 3 milliampere change in the IC value, correct collector current, and 15 microampere change in the base current of the amplifier. The input resistance and voltage gain are. Okay, so pause, do it, and then move ahead. So this is the solution. I've just borrowed the question again, as you could see here, just for your reference. This is the circuit diagram that you should all be able to visualize. Okay, so the thing is, there are 2 formats in NPN transistor, and in our JEE main syllabus, we have only common emitter configuration. That means the emitter is connected to ground. You could see I'm pointing in the diagram here. Okay, so just follow my lead. A lot of things are on the board. So the thing is, when you perform it in DC, right, you get absolute voltages, whereas when you do it with AC signal that you put up at the input side here fluctuates. Okay, there is changes. Okay, so the thing that you need to understand is that when you write a DC equation starting from this position and then go around this particular loop, right, first we do that here, then VCC minus ICRC, and you jump over this. This is C and E gap. So VCC minus ICRC should be VCE. This is the DC form. But you should understand, when you put an AC signal, the changes that you get here are only in the AC form. So it's as good as taking delta on both sides. Delta is a change. Delta VCC is 0. There's no change here. You could see this is a DC battery. So you end up getting minus delta IC into RC here, and delta VC is nothing but the output voltage change. So this would be V out. Now, why did I not write delta? This V out is an AC answer, so which itself is a delta value of this. That's the symbolic way of writing things. Similarly, on the DC side or input side also, you could say that the VBB is not going to change. The change in delta IB is due to the input signal itself, which is the AC value. Okay, so delta IB is given as 15 microampere and delta IC is given as 3 milliampere. The value of R out has been mentioned as R out is this thing, RC is the R out, which is 1000 ohm. V in, which is the signal voltage, that signal voltage is, remember, AC signal voltage. So this is the AC value, should be equal to R in into delta IB. I said the same loop form that I write here, and delta, this one value would be 0. So you get this. So then R in, you can substitute the given numbers and you get the value of R in, which is one of the answers. The second one is V out has to be R out into delta IC. I'm just using this one in the form of R out. R out is RC. So that you can estimate it to be 3 volt, and therefore voltage gain is V out divided by V in, which comes out to be 300. So the required answer in this particular problem is correspondingly 0.67 and 300, which is the first answer. Okay, so that should be a very clear cut and simplistic way to solve. The next question, two magnetic dipoles of X and Y are placed at a separation of d distance with their axis perpendicular to each other. You could see them. Okay, dipole moment of Y is twice that of X. You can see at 2m and m. A particle of charge q is passing through their midpoint here at an angle 45 degrees with the horizontal line as shown in the figure. What would be the magnitude of the force on the particle at that instant? Okay, so he's obviously asking magnetic force. D is much larger than the dimensions of the dipole. Okay, so pause, do, and move on. So this is a solution that we are looking at. He's asking magnetic force. First and foremost, you need to know how to write the magnetic field on an axis and also on the equator of a magnetic dipole or a bar magnet. Okay, so just like your electric dipole, the formula are very simple. Axial point magnetic field is given by mu naught by 4.2. Here the 2 is important, 2 times of m bar divided by r cube. So on the axial point, the field is actually parallel to the dipole moment. So if this m bar is this way, at this place, which is the axis point here, it will be like this. Be equatorial, whereas 2 changes, 2 vanishes, it will become 1, and then m bar becomes reverse. So on the equatorial line, that is this line is equatorial line for this, the field would be anti-parallel to m, and it would be this formula. And these two values, because of the way the m and 2m have been adjusted, these two values come out to be equal in this particular problem. Okay, so once they are equal, the net magnetic field will become at a 45-degree angle, which in essence was nothing but the velocity that was carefully given. So b net and v will become parallel to each other, and once they are parallel, q into v cross b force becomes 0. So this was very simple, but you need to have a very good knowledge of the formula for short dipoles. And please don't use this formula when the dipoles are not short. In one of the past exams, they did ask for the larger dipoles also, which you should refer to your NCRT. Okay, next one. This is 8th April shift 2, as you could see. A common emitter amplifier circuit built using an NPN transistor is shown in the figure. It's DC current gain. So you have to judge whether he's using it in DC or AC, as I said in the previous problem also. So DC he's talking about is 250, RC, which is this number, is 1 kilo ohm, and VCC, this battery value, is 10 volt. What is the minimum base current for VCE to reach saturation? Okay, so pause, do, and move on. And the solution is that in any common emitter amplifier circuit as per NCRT, you need to know two important modes, actually three important modes. One is the cutoff mode, second one is the active mode, and third one is the saturation. Active mode is the one that in which you use it as an amplifier, but the switch is another application in which you want cutoff and saturation. So here he's talking about saturation. So let's see in the solution. Again, lot of things, just follow my lead. I have redrawn that particular circuit here, and I've talked about two important loops. Always two important loops in any common emitter amplifier is to travel from B to E and travel from E to C, like this. Okay, and DC working, as I already told you, output voltage is nothing but VCE and input voltage is the VBE. Okay, and output current is always the IC and input current is always IB. Okay, and beta of DC is IC by IB. In the previous problem, we talked about beta of AC, which is delta IC by delta IB. So both are actually different, but if nothing is mentioned, you take both as same as per NCRT. In one of the solved examples, he does the same. Okay, right, but they are actually different. In this problem, he wants saturation. Okay, so I've just pasted the diagram from your NCRT book that you should be reading in NPN transistors. Okay, right. So in this particular aspect, you could see the regions are clearly marked with output voltage versus input voltage graph. Okay, so the cutoff region is this. Active region is where you end up having VO and VI as a linear function, and saturation region is this. Okay, you could see in the saturation region, the value of output voltage is 0. Output voltage becomes 0. That's how you remember the saturation region. So saturation region implies VC is equal to 0. Just in case for a future question, cutoff region is the one, you should understand, cut off means the current is off. Okay, so the output current will become 0 in that region, and therefore the output voltage would be very large. Remember, VCC minus ICRC, right? IC itself is 0, then the VCC itself becomes VC. That's why your output voltage is very large. But the correct definition for cutoff voltage, which is nothing but the current output equal to 0. So these are the two things you need to remember. So if I travel the loop 2, because all the numbers are given there, I've just marked 10 volt and 1 kilo ohm. VCC minus ICRC is equal to VCE, which should be equal to 0 as per saturation. Okay, so you get the value of IC, and beta has been given, right, this ratio. Therefore IC is known, beta is known. You should get the value of IB, which is 40 microampere. So the required answer in this case should be 40 microampere. Okay, so let's move forward to the next question. This is line of sight communication, quite often asked for the distance and the receiving antenna length and all that stuff. So let's see. In a line of sight radio communication, a distance of about 50 kilometer is kept between the transmitting and receiving antennas. If the height of the receiving antenna is 70 meter, then the minimum height of the transmitting antenna should be, radius of earth is 6,400 kilometers. Okay, so let's see what we can do with this. So I've just borrowed the question again. So you should understand, I have taken a simple picture of the earth with the heights of the antenna. So one of them is transmitting, one of them is the receiver. Okay, right? If the signal has line of sight, means it should go along a straight line. So minimum thing that should happen is the straight line should be tangent to the circle. Okay, right? So you, if I do the H1 D1 R calculation, so remember this forms a right angle triangle with this as R plus H1. So I use the Pythagoras theorem here. I end up getting D1 is this number. But in our textbooks, we consider these heights are very small. You could see these are just 70 meter height. So this formula can be remembered for R to be very large as root 2R H1. So this is something that I would request you to remember. Similarly, D2 side would yield this particular number, and therefore the distance between them, which he's talking about 50 kilometers, straight line distance, you can't go along a curve, right? It's very small. So that 50 kilometers should be sum of those two square roots. Everything else is given in this problem except H2. Get the value of H2, which is approximately 32 meters. So, okay, so I hope that makes sense, and you should be remembering all of this for the exam. Next one. This is on Reynolds number. Okay, so water from a pipe is coming at a rate of 100 liters per minute. Okay, if the radius of the pipe is 5 centimeters, the Reynolds number for the flow is of the order of, okay, order of Reynolds number is asking. Density is given and coefficient of viscosity for water in certain units. So this is milli, please understand, you should convert it into SI. So you want to do it, pause, and then we'll move on. Okay, right. So this is the thing. There are certain other side notes also that are required in this problem. So we'll see those side. I have written NCRT. We'll come to that. Okay. So for the question, Reynolds number for a cylindrical pipe, that's what is there in NCRT. So cylindrical pipe is rho v into diameter. Please do remember this is diameter, not radius. So we have to convert this 5 to 10. And divided by eta. Eta is the coefficient of viscosity. Okay, so and he didn't give v velocity directly, he gave the volume flow rate. Can you see that AV has been given as 100 liter per minute? So one more exercise that you have to do is to convert all these into meter cubes and seconds. Okay, so upon substituting all these values that has been given, area of that cross section is that pi d square by 4, right, for this thing. After a lot of calculation, I ended up getting the Reynolds number as 2 into 10 power 4. Okay, so two side notes. First of all, in future, any Reynolds number question as per NCRT, he could ask steady and turbulent. Remember, all REs which are less than 1000 are steady flows. All REs greater than 2000 is turbulent. And if it lies in between, then it fluctuates between steady and turbulent. It fluctuates between the two. So such fluctuation where you can't say it is steady or turbulent is called unsteady. Okay, right. So this is something that you need to remember. Second important thing, whenever numbers are written in the scientific form, this number is supposed to be called order only if this number is less than or equal to 5. Anything which is greater than 5, and then you have to increase this by a particular value. For example, Avogadro number 6.023 into 10 power 23. Order is not 10 power 23, it's 10 power 24. One small thing you need to remember is if it's exactly 5, then you have to take the same number. So only if this number is strictly greater than 5, then you have to rise this one. Okay, so this is also something you need to remember for a future question. A paramagnetic material has 10 power 28 atoms per meter cube. Its magnetic susceptibility at temperature 350 Kelvin is given as some number. Its susceptibility at 300 Kelvin is. Okay, right. So this is 12th January. So we have entered January shift 2. Okay, so let's move ahead. something that you need to realize is that there are two laws in paramagnetic and ferromagnetic materials, often confused actually. So both are not required for this question. I've just written both so that you can have an idea. Curie's law for a pure paramagnet is given by magnetic susceptibility is directly proportional to 1 by temperature, or inversely proportional to absolute temperature, which is what this question is all about. Okay, right? And since he is given chi at one place at a temperature 350, is asking at other 300. Actually, this is a very naughty question, right? And from JEE mains people, that this number is unnecessary just to distract students. So he has just given chi2 is equal to T1 by T2 into chi1. Just substitute these three numbers, get this number, and mark the option. I think this is option A. But for a future question, you should remember this law is called Curie's law for pure paramagnet substance like this. Whereas a ferromagnetic substance, when heated, can become para and finally come back. It's like ice-water transition that takes place. Similarly, here magnetic transition takes place. The law that governs this type of object, where ferro changes to para, is a different law called as Curie-Viers law, where chi is proportional to 1 by T minus Tc, not directly as this one. So where Tc is called the transition temperature or Curie's temperature. So this one, don't apply it here. Okay, when any question gives ferro is changing to para, then apply this one. Okay, so let's move forward. A light wave is incident normally on a glass slab of refractive index 1.5. If 4% of light gets reflected and the amplitude of electric field of incident light is 30 volt per meter, then the amplitude of electric field for the wave propagating in the glass medium will be. Okay, so it's given incident electric field and is asking refracted electric field. Okay, so let's move forward with the solution. So you need to remember this, and this has been asked twice. I have removed one question actually because of lack of time. So for a transparent medium, magnetic permeability is 1. Okay, right. So I'll make another video sometime later why it should be, but remember it for the exam. And the value of the intensity of an electromagnetic wave is given by half epsilon naught into E square into C. Another thing that you have to remember. Okay, this is called amplitude, and you can remove this half and write this as E RMS square if you want to write in form of RMS. And same thing, if I write this is the incident one, let's say, then the refracted one, he said, is 4% lost, right? So I mean reflected, so refracted would be 0.96 I, and in the medium epsilon naught will become dielectric constant times of epsilon naught. So I'm writing epsilon r, okay, relative permittivity, and to E square, and C will become V. So there are two changes that I have made, okay. And with all, so we'll go back to this calculation. So you need to understand what is C. C is nothing but 1 by root of mu naught epsilon naught, where this is permeability and this is magnetic permeability and this is electric permittivity, okay. And V therefore becomes, in any medium, mu naught changes to the product of mu r epsilon r into mu naught epsilon naught. That means both these constants will appear here. And I already told you, transparent medium, you have to substitute mu r is 1, but epsilon r is not 1. Relative permittivity is not 1. Okay, so since refractive index is given as 1.5, which is nothing but C by V, I hope you remember that. Okay, so C by V, you take the ratio of these, cancel out all the things, you will get root of epsilon r is 1.5 according to this relation. Now after getting this, then divide these two equations on this side, you get 0.96 is equal to, all the cancellations happen, and you will end up having this ratio. Remember, this is also 1 by 1.5, and epsilon r I have derived it as 1.5 whole square. Cancelling off important things, you'll get 24 volt per meter. So a lot of stuff that you need to know about this particular question. Okay, so the answer for this comes out to be 24. Next, amplitude modulation. A 100 volt carrier wave is made to vary between 160 volt and 40 volt by a modulating signal. Always modulating signal means message signal. What is the modulation index? Okay, right. So here's the solution for that. The highest value of any carrier voltage is AC, or sorry, any amplitude modulated wave equation. So I have already written these equations in the first 4 videos, one of them. So please make sure you have gone through them. So I'm directly taking the steps here. AC plus AM is equal to 160 volt. AC minus AM is equal to 40 volt. This is the highest value and this is the lowest value as seen by this. So you solve this. AC is 100. He has already given that, unnecessary. Even if these two are given, you should be able to have 100 here. Okay, AM is equal to 60 volt. and modulation index M is always the ratio of amplitude of the modulating signal, that is message signal, divided by carrier wave signal, so which is 0.6 in this question. So it's a simple question that you can solve. Okay, next one, another shift. This is a different exam, so again I picked up an amplitude modulated signal asked with some scary looking graph. Okay, so an AM signal, that means after the entire thing has been modulated, the graph looks like this, it seems. And which of the following best describes the above signal he's asking. Okay, so he has given 4 informations, 2 on voltages and 2 on times. Okay, so we want to have a try and then go forward. Okay, here there should be an into, here there is a printing error, this should be an into. Okay, right, this is the solution. So I pick the graph again, right? I already told you highest value of any AM wave is given by AM plus AC is 10 volt, and the lowest value is 8 volt, which is AC minus AM. Okay, so solving these two, you'll get AC is 9 and AM is 1. And also the fast variations that are happening is of carrier wave. So the time period of smaller value is the carrier wave time period, TC, and the lazy one that is happening over the top is the message signal time period, which is 100 microsecond. So if I can convert them into the angular frequencies, omega m and omega c come out to be in radian per second here. Okay, and AM wave as a function of time, as I already discussed in the first 4 videos, should be able to write it as AC plus AM into sine omega mt. Remember, AC is supposed to be only here with sine omega ct. What are you modulating? You're changing AC and adding AC with a signal. That means you're changing the amplitude as a function of time. That's why it's called amplitude modulation. Okay, so this is it, and you have to substitute all these numbers, and I think you end up getting the C as the correct answer. You just check it out. Okay, next one. A paramagnetic substance in the form of a cube with sides 11 centimeter has a magnetic dipole moment of some SI units when magnetic intensity is 60 into 10 power 3 ampere per meter. Most of the problems of this chapter could be done if you don't remember the names, also using dimensions. Okay, what are the units and all that. So its magnetic susceptibility is. Okay, so let's forward and paramagnetic substance again. This time another concept that is asked is, you should remember what is meant by magnetization. Okay, magnetization, capital M, is equal to magnetic dipole moment per unit volume. Okay, it's magnetic dipole moment per unit volume, and also the magnetization is directly proportional to H, which with chi as the proportionality. Chi is the magnetic susceptibility, H is the magnetic intensity. Since chi is a pure number, your capital M and capital H should have same units, which in turn means this and this, you can check, are of same units. Okay, these two are same. So he didn't want you to realize that, that's why he has given in different forms, but these two units are same. So he's just asking you chi, which is the ratio of the two numbers, substitute, divided by the volume. Okay, right? So sorry, capital M and H should be having same units, so this one divided by volume should be of the same units as this. Okay, these two are not same. This one divided by volume is the same, and the volume can be found out from 11 cube here. Okay, substitute all the three numbers, you'll get this answer. Okay, right, so that's it. Next one. In the given circuit, the current through a Zener diode is close to. So he has given, I have done almost 3 to 4 problems in the last 4 videos on Zener diodes. They were elaborately done. So this is looking slightly different. That's why I took it out. And there was a lot of controversy in this particular question with printing not complete. Okay. So if this is R1, this is R2, and there is a Zener and there is another load at this particular place. Okay. Right. So let's move forward. I have redrawn it, and one of the few things here is that the person in the exam didn't give what's the value of this is, but R2 and R2 symbol means this, if this is 1500, this should be taken as 1500 is what he has taken in the final answer. Okay, so that's what I have written here. R2 is 1500, and if the current flowing through Zener is I2, the current flowing through outer load is I1, then since these two are parallel and these two resistances are same, if this is I1, this also should be flowing through I1. And since he marked 10 volt as the voltage across this, these two individual I1 values can be found out directly. So if I go from here and go along a loop like this and come back, then 12 minus 500 times of 2I1 plus I2 minus 10 volts should be 0. Therefore, 2i1 plus i2 comes out to be this many amperes. Not only that, i1 times of 1500 should also be equal to 10 volt. You get i1 is 1 by 150. The difficulty here for the students on that exam day was to appropriate the value of i1 and get the i2, which was the breakdown current. We were getting negative value. So which means even before this circuit has started, the diode has been made into a breakdown. So the appropriate answer that you have to mark is not a negative one. You anyway don't have options, but the values have been adjusted in such a way that you should know that it breaks down immediately after connecting it in the circuit. So answer for this is approximately 0. Okay, which this was slightly difficult question to decipher in the exam. Next one. At some location on Earth, the horizontal component of Earth's magnetic field is 18 into 10 power minus 6 Tesla. At this location, the magnetic needle of length 0.12 meter and pole strength of 1.8 ampere meter is suspended from its midpoint using a thread. It makes 45-degree angle with horizontal in equilibrium. To keep this needle horizontal, it seems, the vertical force that should be applied at one of its ends is. Okay, so I want to have a try. Go ahead. I'm going ahead with the solution. So this one. So the thing is, initially when you hang a bar magnet or a magnetic needle, both are the same, it seems it was pointing in a 45-degree direction, which tells you this 45-degree is the dip angle. Okay, so that will only happen if the vertical component and horizontal component are equal to each other. So whatever is this horizontal component he gave, vertical component is also the same. So each of these numbers would be b by root 2. Okay, now in order to push it down, you need to apply a force, can you see, in this direction, so that the torque is balanced. Okay, so the thing is, now in this scenario, the horizontal component will not apply a torque. Remember, magnetic dipole moment and external magnetic field, there is a m cross b torque. So that cross product will be only available due to the vertical component. Okay, so the torque balance in this particular place should be F into L by 2 equal to magnetic dipole moment multiplied by, actually this should be vertical component of magnetic field. Because of 45-degree, magnitude wise this should be equal to the horizontal component. Okay, not only that, he didn't directly give the magnetic dipole moment of the bar magnet. You should know that it is nothing but a product of pole strength and length. This pole strength and length, or you can check the units, ampere meter square is the value of the magnetic dipole moment. Okay, so substituting all the values, you get the required answer for the force as 6.48. I think closest value is 6.5 into 10 power minus 5 Newton. Okay, right. Next one, again AM waves. Modulation frequency of AM radio station is 250 kilohertz, which is 10% of the carrier wave. Okay, if another AM station approaches you for license, what broadcast frequency will you allot? So this was a very good question. So just have a try and then I'll go ahead with the solution. So here it is. First of all, you should realize, and in the last 4 videos, one of the videos discussed that the AM signal has 3 frequencies. Okay, right? I wrote even in the previous question that product of 2 things, right? So in that, the graph was drawn, you can split it into 3 frequencies. One is FC minus FM, FC and FC plus FM. Such a thing in future, if someone asks what is the bandwidth is always the highest frequency minus lowest frequency, which is 2 times the frequency of this modulation frequency. Okay, or message frequency, and that's not asked in this question. Okay, then here FC is 10 times FM because he gave this 10%, which comes out to be 2500 kilohertz. So you know the 3 frequencies, therefore the broadcast frequency of the present AM radio station lies between 2250 and 2750 kilohertz. Therefore the new station, if it approaches you, obviously you should not give any license in between these 2 numbers. So the answer should not lie between these 2. So if you check these 4, these 2 don't lie. But it's a JEE mains exam, you have to mark only one option, right? So the thing is, not only it should not lie, but if you want the best choice, it should lie as far as away from these ends. Okay, so 2000 is far away from this on this side at 250 number, and on this side 2900 is much closer. So best choice out of the 4 therefore would be 2000 kilohertz. That was the difficulty of this particular question. Okay, right. Next one. A 2-watt carbon resistor is color coded with green, black, and red and brown respectively. The maximum current which can be passed through this resistor is. This is a nightmarish question for professors because we generally don't remember. I'm an electrical engineer, so I do remember it. But a lot of us, we don't remember the color coding. It's left to the students. Okay, so but every 3 exams they ask one question. So if you are very lucky, you'll get this question. So this is the way my students break the code. Okay, right? So this credit goes to my students. They came up with the way to remember the color coding of a resistor. Okay, right? So you could see black, brown. You should just remember at least black first. Okay, brown, red, orange, yellow, green, this way, all these colors that are there. These are the digits associated, and these are the multipliers. 10 power 0, 10 power 1. This is there also in NCRT, but in NCRT only tolerances were given in the last 3. These numbers were not given. And this was a very naughty question from JEE mains NTA people, that they are asking Brown also, for whom the tolerance is not known from NCRT. But he didn't ask about that, so it was just off-putting for the students. In the question he's not asking percentage, but if he asks in the future, these are the numbers. Okay, right? So the best way to remember this is BB Roy. So all these yellow capital letters are the ones in this sequence. Okay, so BB Roy, Great Britain, very gorgeous wife. Okay, whatever they came up with. Okay, so it's their invention. So this is how my students remember it. Okay, so in the sequence, you could see here the first one is green. So green becomes the digit. Okay, so this is 5. The next one is also the digit, which is the um, what is given? Black is given, so 0, that is 50. And the third one is the multiplier. So red multiplier is 10 power 2, right? So into 10 power 2. And he had he asked the tolerance, it would have been plus or minus brown, which is the 1%. Okay, right? And the power is related to I square R. R is only this green part value. Power is given as 2 watt. You should be getting 20 milliampere. Yeah, that's it. That's the answer required. Okay, right? So next one. uh, this is non-ideal transformer. Okay, so this was one time they asked it. Already we have done ideal transformer and its concepts in the previous videos, first 4. So links are in the description below, so please go through them. A power transmission line feeds input power at 2300 volt to a step down transformer with its primary windings having 4000 turns. The output power is delivered at 230 volt by the transformer if the current in the primary of the transformer is 5 ampere and its efficiency is 90%. The output current would be. Okay, so here's the solution. For any non-ideal transformer, efficiency is output volt power divided by input power. Remember, in the ideal one, we equate these two, numerator and denominator. Here the fraction of efficiency is this. You just rearrange and substitute the required values carefully. 90% I substituted as 0.9, and rest of the numbers that you can find out. The unnecessary part that is given in this question, always they do this at times, and you have seen in previous questions also, is to confuse students where to use this. You need not. You just pick the numbers that are there and stay calm in the exam. I think you should get the answer. Okay, right? Easier said than done, but try it out. Okay, next one. Diodes. Germanium and silicon diodes start conducting at 0.3 volt and 0.7 volt. These are called knee voltages. Okay, in the following figure, if germanium diode connection was reversed, initially whatever connection is there, they are reversing, the value of V0, which is output voltage, changes by. Assume the germanium diode has large breakdown voltage. Okay, so that it doesn't break down, he's trying to concentrate on. Okay, so let's move forward. The thing is, when you connect this one in the original circuit, the voltage always rises, and you should realize that germanium conducts first. Remember, this number becomes 0.3 first. It won't get a chance to conduct the silicon. So the first time the circuit conduction will happen along this path, and therefore 12 minus 0.3 is the initial value of VO. But when you reverse this, then there is no other choice but silicon to conduct in the second scenario. Then the conducting path would be this, and then VO would be 12 minus 0.7. So the change in VO is minus 0.4, but he only asked for the magnitude of the changes by, he said. So the best answer among the 4 is 0.4 volt. Okay. Next one. Mobility of an electron in a semiconductor is defined as the ratio of the drift velocity to the applied electric field. He need not give this actually, it's there in NCERT. Next time he may not. If for an n-type semiconductor, the density of electrons is 10 power 19 per meter cube and their mobility is given in SI units this way, then the resistivity of the semiconductor, and since she's talking about a semiconductor, n-type semiconductor, you can ignore the number of holes, okay, in terms of the electrons is close to, okay. So let's move ahead. The two important formulae that we all know, actually this should be J equal to NEVD plus NEVD of the holes also, but since he asked me to ignore, I'm taking it as almost Ohm's law. Otherwise, Ohm's law is actually not valid for semiconductors. So NEVD and mobility is defined as VD by E. So combining the two, I'll get J is equal to NE into mu into E. And we all know this is the conductivity, J equal to sigma E, right? So resistivity is reverse of that. Substitute nicely the three values that he has given, N, E and mu, and E should be, you all know that 1.6 into 10 power minus 19. When you do that, you end up getting 4 into 4 ohm meter. Okay, right. So next one. A bar magnet is demagnetized by inserting it inside a solenoid of length 0.2 meter, 100 turns, and carrying a current of 5.2 ampere. The coercivity of the bar magnet is retentivity, coercivity, one of the videos in the first three, I guess. So please do go through those videos. Okay, right. So let's move forward. This was the graph of hysteresis loop that you should understand, that this point on the vertical axis is called retentivity if it is drawn with capital B, and remanence if it is drawn with capital M. If it is capital B, it is called retentivity. For capital M, it is remanence. Okay, and H on the horizontal axis, this point is called coercivity. It is a measure of reverse field of H that I have to apply in order to drive the capital B to 0 or capital M to 0. That's the definition of this. Okay, right. So you can read all this from NCERT also. So the B of the solenoid we all know is mu into Ni, and B by mu is called H, which is reverse in needed. Okay, so the value of N into I is what he's asking. N is number of turns per unit length into this. So you can even manipulate the numbers to get the answer, but that's not the correct way. In future, he may ask a difficult question, and that's how you should get the concept right. Okay, so this is the required answer, and the 2600 ampere per meter. Okay, so all the best for your exam, right, in case you are writing it within the next few days. And please make sure, if you are still having time, you please go through the all first 4 videos and this highlight video thoroughly, and correspondingly please do go through the concepts of NCERT. Minimum of 2 questions and maximum of 7 to 8 questions at times, if you are unlucky, might come from these extra syllabus topics. And even I think 10 marks in the scenario of a JEE mains exam will throw the ranks into hundreds and thousands of changes. Okay, so please make sure you don't make that mistake of ignoring this syllabus. Okay, I put in a lot of effort to actually do this, right? It's almost what, 4:30 a.m. in the morning. Okay, so make sure that you spread this video and the rest of the channel, and please do check out the rest of the series once you are done with your JEE mains exam. The remaining series which are important are on screen, and the links of these playlists are in the description below. And please do like, share and subscribe to the channel. And if in case you like the video, immediately press the like button, because it's very important for the YouTube algorithm to recognize my channel and show it to others. You put more likes, it will go to more people and they have a chance to subscribe to my channel. Okay, so that's how I found out it's going to happen. Okay, so all the best, stay safe, and please make sure you take all the precautions that are required during the corona period. Be conscious. Okay, so as long as you're outside the exam hall, be conscious about the virus, have all the precautions, don't think about the exam, just think about your life. Once you go into the exam and you sit in front of the computer and question starts flashing, it's only a challenge between you and the exam. Virus will not play any role. So once you are inside, just concentrate and hope you do well. Okay, and reach your potential. Thank you. See you in the next video.